welcome to Lab 2. Our goal in Lab 2 was to recreate the model we used in Lab 1 using distributed line charges and superposition in GlowScript. The use of superposition and treating the tape as a set of point particles will increase the accuracy of our results and our model. So we used a couple of physics principles. We used Coulomb's force law. This was to calculate the force between the two charged pieces. So we would use this equation to find the charge because we would already have the force, and we would have the force because of Newton's third law. We use Newton's third law to establish that gravitational force is the same magnitude as the electromagnetic force when the tape is held in equilibrium. We also used F equals mg. This is because we knew that when the object was in equilibrium, the gravitational force was equal to the electromagnetic force, and the gravitational force was the weight of the tape. And the weight of the tape was the mass times the Earth's gravitational constant. And then in addition to, in this lab, we used the principle of superposition because we treated the tape as a set of multiple point charges. And so the sum of all the point charges added up to the overall charge of the tape. So this is the method for our physical method. We laid two tapes of similar length on top of each other such that one tape's sticky side is stuck to the other non-sticky side. We quickly ripped the two tapes apart, and then we did this for two sets, so that way we got two pieces of tape with the same charge. We set one of the tapes in between two objects. Then from below, we brought the second tape slowly upwards from underneath the first until the top tape started to float. And then we measured the distance between the tapes at this point. We made a couple assumptions in this experiment. One of them was that each piece has the same charge. This is not necessarily true. And also that the charge was evenly distributed throughout the tape. Then there were no external forces other than gravity and the electromagnetic force. So there's no air resistance or anything like that. And then also the mass of the tape is accurate according to the ratio we were given. So we were given a ratio, and that's not necessarily true for all the tapes, but that's another assumption that we made. Here are some of the measurements and results. The length of the tape was 20 centimeters. The mass of the tape was 2 kg. The distance between the tapes was 0.027 meters. The magnitude of the gravitation, that was the distance between the tapes, when tape above started floating. The magnitude of the gravitational force in the tape was 1.96 times 10 to the minus 3. The magnitude of the electric force in the tape was 1.96 times 10 to the minus 3. And because we know this because of Newton's third law. And the charge of the tape, using calculations, we got was 1.26 times 10 to the minus 8 coulombs. So here's the GlowScript code. So first, I put in the constants, that is 1 over 4 pi epsilon, and g equals 9.8. Then my measurements, and then the estimated net charge of one tape. That was done using calculations. And then on the bottom we can see that this is the E field of one of the charged particles. This is of one of the charged particles. So it's the same equation, but we would just be repeating this, and I'll show you later. So now here we have a loop that's iterated, and so it creates this line of charged particles, and then using that it calculates the E field at the location at the top of the tape. And now here are the two models. As you can see, in lab 1 we treated it as point particles. Each tape is a point particle, and we got a charge of 1.26 times 10 to the minus 8. However, in lab 2, we treated each piece of tape, the tape, as a set of point particles, and each of these point particles went interacting with each of the other point particles in the other tape. And so we got Q equals 3.3228 e to the minus 8. We think our second model is much more accurate to what the real life representation, although not completely accurate. Thank you.